Okay, folks, let's take a look at this. Again, this is sort of just another example based on our last problem. This problem, you know, we changed the stirrup spacing around. Now we've got we got the 3-inch locator stirrup out from the face, but then we got 10 at 6, and we got 5 at 10. The real difference in this is going to be, we're going to get out after this first initial stirrup spacing, 10 at 6 inches, and we're going to drop down. We're going to drop down because we went to a bigger stirrup spacing, or a larger stirrup spacing. So, anyway, the first time around, we already did the calculation for design capacity at 6 inches. And that design capacity was what? 56? All right? So, I mean, up to this point here, we're going to be fine. Because the design capacity is the same as what we calculated back in our first example. It's 56 kips. That's greater than the VU critical, which was 46.6. So, hey, phi VN greater than or equal to V sub U. It works. But then, all of a sudden, now we're making this spacing change. And what we have to do is we have to calculate what phi VN will be when we have this 10-inch spacing. Now again, we know what VC is. We know what phi is. What we need to know is what is VS when we're using the 10-inch spacing. So VS is AV FY D divided by 10. What is V sub S? 26.4 kips. Everybody agree with that? So then phi VN, when I'm using this new 10-inch spacing, is phi is 0.75. V sub C is what? 30.7, and our new V sub S with a 10-inch spacing is 26.4. So, what is my new phi VN? So, 42.8. So, when I make the change from 6 inches to 10 inches, this is going to drop down to its new value, 42.8 kips. Now the question becomes, I mean, I'm just doing this up on the board. Hey, my scale could be off. I don't really, you know, who says I'm a great graphic person up on the board? This could all be. What would happen if this dropped down below this green line? It would say I failed because phi VN would not be greater than V sub U. So I guess my question is, how do I know what this point is right here on this line? You do a straight line equation again. Okay? Application of a straight line equation. This point, I want to make sure this point's less than 42.8 because that's what my capacity is going down to. So, what value am I solving for? Well, we'll just call that VU. What's my slope? -5. How far out am I going in the x direction? 63. I'll take 63 inches divided by 12. Where's my line start at? 55. All right? No, the blue line's 56. The green line starts at 55. Okay? So what is that? 28.75. Does that make you feel good or bad? Good, because I changed my stirrup spacings. My stirrup spacings dropped down to 42.8. It gives me a capacity of 42.8. But that's still greater than what I need. So now that capacity stays the same as long as I have the 10-inch spacing until what happens? till the stirrups end again. This was like our first example. Hey, I drop down to phi VC, but what the code says is where you don't have stirrups, that's great to drop down to phi VC, and that's like 23 kips. But the code says, hey, you gotta have a VU, or you can only drop off to where you're not using stirrups, where your VU is less than phi VC divided by 2. So this is the same thing we did the first time around. Is VU less than phi VC over 2, which I think the first time we said was 11.5 kips. Well, how far out are we? Well, we're 63 plus another 50, so we're 113 inches out. Again, we're asking ourselves, what's this value? Okay? So what is that value? Minus 5. I'm 113 inches out. And that value is 7.75. Is 7.75 less than phi VC over 2? Okay, then I'm good. So all is well. All right?